Hi, this is Brian Kim. I'm going to share with you case number 115 in the best way to do cataract surgery series. This is a cataract, and you're going to see cross chop, all sorts of chop, but more importantly, terminal chop. I'm going to be able to conquer the posterior plate by sculpting a central area and then from the equatorial side, fracturing the lens. And by doing it that way, you're able to get a deep, deep chop which fractures through the posterior plate. And so to me, this is really the safest and most efficient way to avoid the posterior plate in these very, very dense lenses. So I'm using a cotton tip to steady the eye, and then I'm using a corneal marker, which helps me to center in Scissorhexis. And then I'm using my diamond blade to make paracentesis incision, first on the right side and then the left side, making sure I'm flat to the iris plane, which will create a nice corneal shelf and allow me to achieve a self-sealing incision. This is intracameral lidocaine and then some intracameral epinephrine. I go ahead and put some intracameral air, and then this is trypan blue. I'm going to paint the anterior capsule surface. Got a nice bubble, and then just dripping and painting the anterior capsule surface, trying not to flood the eye with the dye. With these dense lenses, trypan blue is really very, very advantageous. You really don't want to take a chance and have a complication in this situation. Fill the eye with some dispersive viscoelastic. And this is a triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel, and then using the cannula to control it, and then I enter. Push some more viscoelastic in. I'm going to start with the puncture style rhexis. Let's see how this goes. Go ahead and puncture. And that didn't quite work, so I go ahead and switch to the cystotome. Again, I don't want to stress the zonules. You could see that the lens is wobbly, quite a bit wobbly. And so, yeah, you don't want to stress the zonules in this case. Again, it's been my experience, really dense lenses tend to be associated with loose zonules. And so that also is confirmed in this case. So now that we have a flap due to the cystotome, I'm able to grab the right side of the flap with the rhexis forceps and then start going around circumferentially here. And this is the Capsulorhexis hydrodissection technique. I place a cannula under the rhexis edge, contra-incisionally, get a nice wave, decompress on the left side, and then hooking the lens on the right side, and it spins. I made a weak attempt to hydrodelineate here, but the lens is so dense, I don't think it really did anything there. Irrigating the surface of the eye here, adjusting my sleeve. Lifting the incision with the chopper, going in with irrigation off. I'm actually bevel up here now because I know I'm going to sculpt. So I'm in sculpt mode. I'm going to start to sculpt in the center here. What you want to do is debulk most of the anterior lens material. So really that's the key. You don't want to go all the way down to the bottom. I don't have to worry about the red reflex. Oh, you want to keep going down so you can start to see the reflex changing. You know, that's kind of the typical sculpting kind of rules. I don't really care about that. I want to sculpt down to, you know, about half, maybe a little bit more, but not anything near like you do for the traditional sculpting maneuvers, because you're not going to be cracking from within the trough. I think cracking within the trough is one of the most inefficient ways to fracture the lens. So you can see I'm placing the chopper around the lens at the level of the equator, and then I'm separating the lens and cracking it from the equatorial side. And that didn't quite work, so I'm doing it again. So you can see it's separated, but it's only separated on that side. It's almost like Pac-Man. So I'm going to go around on the other side, going around. I'm sculpting a little bit more, placing the chopper around the lens. Again, from the equatorial side, I'm fracturing from the edge of the lens, bringing the chopper towards the phaco tip, crushing it, and then dividing the lens. Now you can start to see the red reflex coming through completely. And so that means I don't have a posterior plate. So now I'm kind of turning bevel down in my normal customary position. I have two pieces. They're not even sized pieces. The piece underneath me is a bigger piece. The piece away from me is smaller. Place the chopper around the lens piece, around that first heminucleus, pulling it towards the phaco tip, crushing and dividing the lens piece. Pulling that first quadrant up out of the bag, amputating the deeper attachment right there, using that scissoring maneuver with the two instruments to amputate that piece from the remaining piece of the lens, because there are some leathery adhesions, and then crushing the lens pieces into smaller pieces, and then carefully emulsifying the lens piece. Placing the chopper around the lens piece, pulling it centrally. There's some adhesions again, so I'm going to use that scissoring technique maneuver, amputating the posterior adhesions by separating the lens completely with mechanical forces. Now I'm able to emulsify the lens piece. So with those dense lenses, that scissoring chop maneuver has been really effective for me. It's very safe because you're scissoring from within a given plane. You're not doing an anterior to posterior chop maneuver, which can be a little bit dicey in this situation. Trying to get that piece up, it's a little bit stubborn. It won't want to come up here. So I just ignore that piece and go after another side, placing the chopper around the lens piece. But then I stop, I come out, just want to fill the eye with some more viscoelastic. And the reason being is I feel like the tip is clogged. So the tip is clogged. I felt that as I was trying to emulsify the lens pieces, it wasn't happening efficiently. And that was part of the reason why I struggled with that first piece. And so that's what you're seeing here. I'm asking the technician to look at the handpiece, flush it out. And you know, that's one of the things about dense lenses, that you can have clogging of the tip. When I was doing phaco down in the Dominican Republic, we were doing really dense cataracts on infinities there. And so that's one of the reasons why I think that this technique is so powerful. When I went down to the mission field, I was doing these ultraluminescent, they're not even, they're like cataracts times 10. And so I was able to phaco these really challenging lenses and have clear corneas post-op day one, which I was totally shocked. But during those cases, I was having a lot of clogging. And so I had to stop and unclog the tip on many occasions. And so this case is really another example of that. So I placed the chopper around the lens piece. I come back, and then I was able to fracture the lens piece. I'm just trying to separate the pieces. Again, there's some leathery adhesions, very carefully separating them. There's still some adhesions there. And then this is that scissoring maneuver. I hook it underneath with the chopper, and then I'm doing a sideways cutting, sideways chopping, and it breaks those posterior adhesions. And then once I do that, it's completely amputated from the bulk of the entire lens, and I can focus on just that one piece, crushing it between the instruments into smaller and smaller pieces. And again, this is a really thick lens. Even these smaller pieces are just hard nuggets. I'm able to very carefully and systematically break up the lens into smaller pieces, and as I go, emulsify the lens pieces. So again, very systematic, very controlled. I'm going after each piece. I'm not worried about breaking the bag. All the maneuvers are way away from the bag. So I turn this other piece in front of me, placing the chopper around the lens piece, pulling it centrally toward the phaco tip, crushing it between the two instruments again. Doing the same maneuver again, trying to get some nice fracture planes there. Again, you can see there are adhesions there. Again, even though I was able to divide that two heminuclei, once you get a heminucleus, you're going to have to fracture the heminuclei, and those also have adhesions. And so that's the way you conquer the adhesions, is you do that scissoring chop, that sideways chop that I was doing right there. And that's a very controlled way, a very safe way to amputate those pieces. You don't have to go after it with ultrasonic energy. You don't have to go after it with vacuum. You don't have to hold the pieces with vacuum. That's when you get into trouble, because these cases, there's no epinucleus to protect you. There's no cortex to protect you. The posterior capsule's right in your face. And so by doing this scissoring maneuver, as you're seeing successively, like right you see here, placing the chopper underneath, holding it sideways, you can see the chopper sideways, and that's why you're able to do that scissoring maneuver within the same plane. I'm able to basically bring the instruments together, and I'm doing a scissoring maneuver to amputate that posterior adhesion from the bulk of the lens. And then you can go after that piece in isolation, crushing it into smaller pieces and then emulsifying the lens piece. Then you go after the remainder of the pieces, crushing and bisecting the lens pieces. Again, because the crushing and dividing of the lens piece is done with only irrigation, you can see all these maneuvers. There's no aspiration, there's no vacuum, there's no phaco during the maneuver. You can see the settings. There's nothing that's happening while I'm doing the cutting and the disassembly of the lens. There's no fluidics except just irrigation. Irrigation is the only thing that's happening when I'm cutting the lens pieces, amputating the lens pieces during double chop, cross chop, the scissoring maneuver, whatever the case is. During the cutting of the lens, there's no aspiration, there's no vacuum, there's no ultrasonic energy. And as a result, during that moment, I have exquisite control over the eye, exquisite control over what's going on. And as a result, I don't tend to break bag during that step. And, unfortunately, with other techniques, you can break bag while you're trying to disassemble the lens. Why? Because you're sculpting, you're trying to lollipop the lens, you're trying to go after pieces and hold it, and then grabbing it with purchasing power, and all that requires vacuum and ultrasonic energy. So I take the chopper out, push BSS in, take the phaco tip out, and I go in with the INE handpiece. You can see this is a very clean bag, but then I'm going to go in with polish mode, just polishing under the Rexis edge. If I see a small piece of Cortex, I switch to Cortex mode and then grab the piece and then switch back to polish mode. So there are some remnants of cortical material that's there. It's very important not to go in Cortex mode and using high vacuum, because if you grab the capsular bag, especially in the dense lenses, they do have weak zonules. You might rip the zonules. So I like to go in with polish mode, especially since the bag looks fairly clean. Yes, there's some equatorial fornicele cortical material that's there underneath the pupil edge there. And so you're able to see I'm able to remove that just very carefully. Pulsing the subincisional capsule fornix. And then I'm injecting the cohesive viscoelastic to fill the bag. And then I'm going to start to polish under the Rexis edge to remove the lens epithelial cells. First on the left side and then the right side. This is a 3-piece lens. I'm going to go ahead and widen the incision with my diamond blade. This is that blade that doesn't cut very well, so Let's see if I'm able to actually get it in there. So I'm pushing, having some trouble. Finally got it in. Turning the barrel to the left, deliver the leading haptic into the bag, which comes out planar. As the optic is delivered, I rotate my right hand counterclockwise about 90 degrees, and the optic comes out as it should. Dial the trailing haptic into the bag with the Maltzman. I go in with irrigation off, activate irrigation, go underneath the lens, removing the viscoelastic from within the bag. Again, the incision is not watertight anymore because I widened the incision, so you have to be very mindful of the fluidics in this situation. Go ahead and switch to visco mode, removing the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, this is ultraluminescent cataract. I've dealt with these cases many times. I've kind of settled down into doing this modified stop and chop technique, debulking the central core of endonucleus, and then fracturing the posterior plate and getting rid of, effectively preventing a posterior plate by fracturing from the equatorial side, which propagates the tear from deep and goes all the way to the other side. If it doesn't go all the way to the other side, you just rotate 180 degrees, do the same thing on the other side. Again, even though you are able to fracture the lens into two pieces, you will still tend to have posterior adhesions. And so that's why that sideways chop maneuver is such an effective and efficient way and safe way to disassemble the lens. And again, this is why I think this is the best way to do cataract surgery, especially in the super dense lens. I hope this was helpful to you, and I thank you for your attention.